This is question number 7 from the MAC 1105 paper test review. So it says for the rational function f at x equals 4x plus 4 over x minus 2. Part A, state the domain in interval notation. B, find the vertical asymptotes if any. C, I'm going to cross out because it says the same thing. D says find the horizontal asymptote if any. E, find the y-intercept if any. And F, find the x-intercept if any. All right, so to find the domain, we have to first figure out what can't be in the domain. So we set the denominator equal to 0 and solve. So this value cannot be in the domain. So if I want to do the domain in interval notation, I'm going to go negative infinity up to 2, union 2 to positive infinity. That's an interval notation. And then part B says find the vertical asymptote if any. So if I look at the denominator, x minus 2 equals 0, and the numerator factors out, actually let me get rid of the equals 0, but the numerator factors out into 4 times x plus 1. I can't cross off anything. If I could cross off either the x plus 1 or the x minus 2, then I would have a hole in the graph. Since I can't do that, I just look at the denominator and I set that equal to 0. So x equals 2 is a vertical asymptote. For the horizontal asymptote, I have to look at the powers. The power of the numerator, which we'll call n, is 1. The power of the denominator, which we'll call m, is also 1. So if n is equal to m, that means the horizontal asymptote is the coefficients of those values. So I have 4x over x. The coefficients are 4 and 1. So the horizontal asymptote is y equals 4. All right, find the y-intercept if any. So for the y-intercept, I'm going to let x equal 0. And if I do that, I get 4 times 0 plus 4 over 0 minus 2. So 4 divided by negative 2 equals negative 2. So the y-intercept is 0, negative 2. F, x-intercepts. So x-intercepts mean I have to let f of x equal 0. So I have 0 equals 4x plus 4 over x minus 2. And if I multiply both sides by x minus 2, we're going to get x minus 2 times 0, which is 0. So 0 equals 4x plus 4. Now, if I factor out a 4, I get 4 times x plus 1 equals 0. 0 equals x plus 1, x equals negative 1. So the x-intercept is negative 1, 0. So now I'm ready to put these values in. The vertical asymptote is x equals 2. The horizontal is 4. So what I'm going to do is go by units of 2 or units of 1 because we have enough room to do this. So I'm doing 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Now I'm going to put the negatives in. Okay, so let's put in the vertical asymptotes. X equals 2. That's right here. I'm going to make the pen a tiny bit thicker here. Okay, and then y equals 4 is the horizontal asymptote, so that's clear up here. Okay, so we have this situation going on. Now I need to put my values in. So the first value I have is 0, negative 2, and then I have, 0, negative 2 is here. Let me erase that. And then the other value I had is negative 1, 0, which is right here. So I can kind of see that this is what's going on with this graph. Okay, on the other side, I have to figure out what's going on. So I need to find at least 2 other points on the other side to be able to graph it. So I'm looking at this quadrant right here that I just put the x in. I'm going to let x equal 3. And if I plug that in, I get 4 times 3 plus 4. over 4 minus 2. So 12 plus 4 over 2, that's 16 divided by 2 is 8. So I get the value 3/8. So that's going to be about right here. So just going to put that in there. 3/8. That's off a little bit. Let me fix that. Okay, so somewhere around in there. And then I'm going to use another value. Let's use 4, just for sake of argument. So 4 times 4 plus 4 over 4 minus 2. And by the way, I did the last one wrong. In the denominator, let's fix that. The last one should say 3 minus 2. And 3 minus 2 is 1. So it should be 16 over 1, which is 16. So that value is going to be way up higher. It's going to be like up in here someplace. Now let's go back to the plugging in 4. So this is x equals 3, x equals 4. I'm going to clean this up a little bit. Okay, so 4 times 4 is 16. 16 and 4 is 20 over 2. So 20 divided by 2 is 10. Okay, so 410. So we can see we've dropped down a little bit. So my graph is going to do that. Okay, so that is my graph for that one. And let's look at number 8. For the rational function f of x equals 3x plus 2 over x squared minus 4, find the domain, find any vertical asymptote, find any horizontal asymptote, find the y-intercept, x-intercept, and graph. All right, so first things first, I'm going to go ahead and factor out that denominator. I have the difference of perfect squares of x squared minus 4. So that factors out into x minus 2, x plus 2. Now, I'm trying to find out where the domain can't be, so I'm setting each of these equal to 0 to solve them. So the domain cannot be x equals 2 and x equals negative 2. So in interval notation, this is going to go negative infinity to negative 2, union, negative 2 to positive 2, union 2 to positive infinity. Okay, vertical asymptotes. Well, I just factored out the denominator. The numerator is 3x plus 2, which I can't cross out anything. So I know for a fact that my asymptotes are going to be y equals 2 and y equals negative 2. Now, horizontal asymptote. So n is the power of the numerator, which is 1, and the power of the denominator is 2. So since n is smaller than m, my horizontal asymptote is y equals 0. E. We're finding the y-intercept, so I'm going to let x equals 0. So I have 3 times 0 plus 2 over 0 squared minus 4. So this becomes 2 over negative 4, which is negative 1/2. So 0, negative 1/2 is the value there. And then f, x-intercepts. So I have to set f of x equal to 0. So 0 equals 3x plus 2 over x squared minus 4. X squared minus 4 times 0 is going to 0 out, and it equals 3x plus 2. So 0 equals 3x plus 2, negative 2 here, x equals negative 2/3. All right, I'm going to now graph what I have. So I'm going to put in the asymptotes. So I have one at 2 and at negative 2. Okay. So there's the one at 2, and here's the one at negative 2. Okay, y equals 0 is right here. So this time around we have 3 regions. So let's put in what we know. 0, negative 1/2. We know that point, so I'm going to go ahead and plot that. I know there's another x-intercept at negative 2, 0. Or negative 2/3, 0, excuse me. Okay. Now I have to figure out the rest of this. Alright, so I'm going to kind of move this into left part, right part, middle part, okay? So I'm going to do the far left first. Now I need 2 values to figure out what's going on. So I'm going to pick x equals negative 3 and x equals negative 4. So I'm plugging in negative 3 into the original equation. So this becomes 3 times negative 3 plus 2 over negative 3 squared minus 4. So this is negative 9 plus 2 over 9 minus 4. So this is negative 7 over 5. And that becomes negative 1 2/5 for plotting purposes. So negative 3, negative 1 2/5. Okay, now let's do x equals negative 4. 3 times negative 4 plus 2 over negative 4 squared minus 4. Negative 12 plus 2 over 16 minus 4. And I get negative 10 over 12. And that reduces down to negative 5/6. So negative 5/6 goes in there. Okay, so I can kind of see what's going on with this is I'm getting this kind of shape. Alright, so the left is done. Now let's work on the middle. Now, when you have 3 regions, remember the graph can go through the horizontal asymptote. So I need to figure out basically what's going on the left of it, of those 2 points that we have, and what's going on the right of it. So I'm going to pick negative 1. And I'm also going to pick another value, and I'm going to pick positive 1. Okay, so I'm going to plug this in. 3 times negative 1 plus 2 over negative 1 squared minus 4. Negative 3 plus 2 over 1 minus 4. So negative 1 over negative 3, which is 1/3. Okay, so negative 1, 1/3. Oh, whoops. I was like, something looks wrong. Negative 1, 1/3 is here. Sorry, guys. Okay. And then I'm going to do x equals 1. So 3 times 1 plus 2 over 1 squared minus 4. This is 5 over negative 3. So this equals negative 1 2/3. Okay, so positive 1. And I have a negative 1 1/3. Okay, so I can kind of see the graph is forming here, and here's what's happening in the middle. Okay, so we have the middle done and the left. Now let's do the right. And I don't have any points here at all, so I need to figure out some. I'm going to go after x equals 3, and I'm also going to go after x equals 4. Okay. So I have 3 times 3 plus 2 over 3 squared minus 4. This becomes 9 plus 2, which is 11, over 9 minus 4, which is 5. So this becomes 2 1/5. And then x equals 4. 3 times 4 plus 2. 4 squared minus 4. This becomes 12 plus 2 is 14. 16 minus 4 is 12. So this becomes 7 over 6, or 1 1/6. Okay, so we can kind of see that the graph is doing this. So if you have 3 regions, you're going to have to plot literally 3 graphs. And remember, you can cross the horizontal asymptote in the middle, but not on the left and right sides. All right, guys, so that was number 7. Or was that number 8? I did number 8. Sorry, guys. Okay, so I did 7 and 8. I'm going to go ahead and stop the video, and I'll pick up on number 9 on the next video. Thanks for watching those two.